All right, back with another video. Topic today, similar to the last video, using the ESPN API to pull fantasy football data. I have the finished product here on the screen. It's just a little bar chart of, on the x-axis we have draft position, so where you're drafting, where each team is drafting, and then on the y-axis we have average win percentage, or under or over the average. So this is for my entire fantasy football league history, which is 4 years. And as you can see, it looks like the first 5 picks or so are marginally better than average. And then we've got a dramatic drop off. The 8th pick is the worst. 6th isn't too great either. And then 9th pick is best. I don't think this is statistically significant. I think there's about 38 data points. We've got 3 full years of fantasy football and 10 teams each, except for the first year we had 8 teams. So I'm not saying this is statistically significant, but it was something I wanted to analyze and look into because a lot of the people were complaining about their draft pick, which I figured didn't really matter. I think given enough time, all of these would be roughly zero, about average win percentage. So I can break down how I did this. Take a look at the code in this Jupyter notebook here. So starting at the top, we'll go through the dependencies. The only dependencies we need are the request library, pandas, and then matplotlib. We're going to use that as our visualization tool. I think there's probably some better ones out there, but this is just a quick analysis. So defining my league ID here. And I talked about it in the last video how to grab your league ID if you don't know where it is. If you go to ESPN.com to your fantasy football league, it's in the URL. So this is the structure of the URL, and we're just using an F string to populate that in. So next, I am defining all of the years of my fantasy football league. So if you're going to recreate this, you're going to need to take a look at how long you've been doing fantasy football and put all of the years in a list, just like I have here in this variable years. So next, we're going to initialize an empty list. So the 2 kinds of data we need here are performance. I'm calling it performance. It's the team view in the ESPN API. And we're going to join that data, which is win percentage, records, win losses, that kind of thing. We're going to join that on draft detail. Let me scroll down. I'll just show you right now. This is a view for draft detail. So we're going to join these 2 data sets together on the unique team ID. But I'm kind of getting ahead of myself here. So we initialize this empty list to hold our performance data, our win-loss data, and we're going to loop through it for each year. So for each year, we're going to get a response using the base URL, and we're appending this, this year to the end of the URL and using the team view. So once we get that response, we transform it into a JSON using this .json function. And when we get that JSON, we append it to our empty performance list. So this list is going to have I can prove it for you here. This list is going to have a length of 4, and each element of the list is just a gigantic JSON string. So as you can see, 4 for our 4 years of fantasy football data. So now that we have that, we're going to parse through each JSON, each year in the list. We're going to initialize a couple empty lists here. The 2 data points we're concerned with are the unique team ID and the win percentage. So this is a fairly complex nested loop here. So I've written this out as a little bit of help. So the top level of the loop, we're looping through each year. And for each year, we're looping through all 10 teams. So for this part here, you can see for I and range, the length of performance. So for each year, we're going to loop through all 10 teams. So I know for my league, at least, there's 10 teams. That's why I have 10 there. And then we're appending this result to our empty lists here. So the first one here, we're appending the ID. So from the performance list, we're identifying, the first element, the ith element, I should say. So that would be our first year, and then our second year, and then our third year. The first element in that list, and then this is kind of just the structure of the JSON. You can print out the JSON variable if you don't believe me, but it's underneath teams, and then for the given team, there's a number, however many down. So we would go first team, second team, third team for that given year, and then we're appending ID to that. And then the same thing, same kind of idea for win percentage. We just go a little bit down in a different route there to get the win percentage. So the reason I have it in this try except clause is because we started the league with 8 people. So only 8 people, and then we ended up adding 2 more people after the first year. So if I left this as 0,8, or if I left this just as 0,10 without the try except clause, it would fail for those first 2 for that first year when we only had 8, because there wouldn't be a 9th and 10th element in the list. So, but yeah, this is the structure of the nested loop. So we're going year 1, team 1, year 1, team 2, all the way to the end. And then once we finish that year, we're going to go however many years. For me, I've limited to the length of this performance variable, which is 4. So, all right. So now the data is in these 2 no longer empty lists. We're going to put those lists into a dictionary, which I'm calling data. So we're defining the team ID as the IDs list and the win percentage as win percentage key as the win percentage list here. From there, we're going to define a pandas data frame, which we're doing here with this pd.dataframe function. And here you can see I printed it out, the results. So we see the team ID and the win percentage, and this is the entire league history here. So you can see there's going to be 38 elements. Python starts at 0, so it ends at 37, but there's 38 elements here. And this is the win percentage of everybody. Whoever this was did not perform very well. Same here. Only probably 1 win that year for those people. But yeah, that's kind of interesting. You can see this is a pretty easy way to get your entire league history, win percentage, in one clean data frame here. Next, we're going to do the same kind of idea, but this time we're going to use the draft detail view. So the ESPN API for fantasy football has a few different views. One of them is draft detail, and up here, one of them is the team view. So right now we're doing draft detail. Same idea, we're creating this empty list called draft. We're going to get a response from the API, transform that response into a JSON, and then append each year's JSON to this empty list. Same exact idea here. We're going to loop through the year, each team, and then we're going to go to the next year, each team again. But this time we want to append the team ID, and then this is kind of confusing. This column for draft detail, the view, the name ID actually represents like the pick in the draft. So ID 1 would be the first pick, and we want to do this for the first 10. So if you print out the JSON, you'll see that it goes it'll be your entire draft, but we're only concerned with the first 10 because we just want to know the order that everyone was in. So we're just doing the first 10 here for each year. And I think I mentioned this earlier. I've labeled it here if you're looking at the GitHub repo, but I'm deleting the 9th and 10th elements in the list because the first year we had 8 people and then we bumped it up to 10. So I'm deleting these because for the first year, if I left those in, it would have been the first and second pick in the second round instead of going to the next year. So this is specific to my league. If your league has been consistent with the number of people, then you don't need to do anything like this. And again, we're putting this data, the lists that we populated in this for loop, into a dictionary, feeding that into a data frame. So we've got the team ID and their draft position here for all 38 elements. So next, we're just joining. This is pretty easy. We made it simple. We're joining on team ID. Those are the only 2 columns that these data frames have in common, so that by default, using this function, they'll join on team ID. And then we can print it out here, and here we go. So we got our team ID, draft position, win percentage. We really only use the team ID field to join the 2 data frames. So I'm going to drop it here by specifying that reassigning the variable df to just be these 2 columns. So next, that's pretty much how you get all the data in one data frame. What you do with it from here on is, kind of up to you. What I did was I defined this win percentage by draft position by grouping our data frame uh, by the draft position and then taking the average of that. So, and then I sorted it here so we can see that, the ninth draft position on average wins 59% of the time, all the way down to eighth position has a 34% win percentage. So, um, that's kind of interesting. Next, we're going to create a variable called average win percentage. So we want to find what the average win percentage is. Obviously, given enough time that this would always average out to 50% for everything. So, and then we're creating a new column in our data frame, which is the distance from that average draft position's win percentage. So to do that, we're looping through each row in our data frame, this column, each row in this column, which is our win percentage by draft position. And then we're subtracting that win percentage by the average win percentage to get the distance from the average. So, and then we are ascending it, we're sorting it again. So you can see, the win percentage and then how much better or worse that position in the draft is. So we can see the ninth draft position wins 9% more than the average draft position, and all the way down to eighth, which wins 16% less than the average draft position. Kind of interesting. And then lastly, we're just plotting it on a bar chart. I'm sure there's a lot more analysis you could do, but I figured I'd make this video because it helps me understand the ESPN API, which has terrible documentation. So hopefully everybody liked this video. I'm going to post a link to the GitHub repo in the description of the video. So if anybody has any questions or wants me to focus on something else specific to the ESPN API or something else entirely, let me know. I'm just getting used to making videos. So thank you.